Hello, everyone. Happy Wednesday. Thank you for joining us today with LP. I'm going to give everyone a few minutes to trickle in and then we'll get started. As everyone's joining the presentation room, I wanted to introduce Sharon. She will be your presenter today. She is with LP Building Solutions. A few things before we get the presentation started. I wanted to show you a few ways that you can connect with LP after the presentation today. The first way, there will be a poll about 3/4 of the way through the presentation. It will provide a series of questions where you can give any project details and you can provide any questions that what you are looking for, whether it be samples, project specific support, or just that project literature that is available to you. Now, two other ways to find LP. The first one here is by going on to Acelab, typing in LP, clicking on the manufacturers here. Oh, just taking its time. And then from there, you can see their brand page here. It's got some really, really great information. Also a good way to connect with Rodrigo, who's in the presentation room today. When you go down, you can explore their products. They have quite a few products here. And then you can explore some inspiration as well, where you can see LP in the real world. And then the last way I'll tell you to connect with LP, in case you would like a meeting for your entire office, a one-on-one meeting, we have our new Meet the Manufacturers page. So if we go down to LP, you can click on this page here, and it will give you a form to fill out with more information and a way to connect with them further. And the last thing, today is an AIA accredited presentation. If you were not able to fill out your number before today's presentation, I will drop a link in the chat. Feel free to complete that so you can get credit for today's presentation. That's everything from my end, and I will let Sharon take it away.
Hi, everybody. I'm Sharon Roscher with LP Building Solutions. I'm the Architectural Business Development Manager. I cover the Southeast. So glad you could join us today and learn a little bit more about treated engineered wood siding. But I'll just go quickly over Louisiana Pacific, and we now go by LP Building Solutions. But Louisiana Pacific Corporation is a global leader in engineered wood building products. We produce about 60% of the mid-grade OSB in the United States and the largest overall engineered wood building product manufacturer with our OSB and our siding business that we cover all of North America and South America. So we were founded in 1973. In fact, if in 1972, if you were buying plywood, chances are you're buying a good portion of that from Georgia Pacific. And so in 1973, the government had Georgia Pacific sell off some of those mills, and those mills actually became Louisiana Pacific, so a totally independent company. And over time, LP actually invented OSB about 1978, and the rest is history. We ended up selling some of those mills off, the plywood mills, and really, introducing better and better engineered wood building products over the years. And LP is traded on the New York Stock Exchange, so we're an exceptionally strong company. We do right by our customers and by the environment, and it's really paid off. So our products really, maybe we don't promote ourselves as well as some of our competitors, but every one of our products is actually is structurally sounder, stronger warranty, really is beneficial in every way. There isn't one product that we make that you can't feel comfortable putting an LP product on the specification of any of your projects. So we have over 4,000 employees worldwide, 24 manufacturing facilities, and over 20 billion square feet of SmartSide sold since 1997. And that's really when we introduced our strand process, or a dry process. And we'll talk about that more in the class, about how that all came to be and why we got away from the wet process. There's still manufacturers that do that. We'll talk about that. But really our mission is, to really have leadership behaviors that you all can feel confident that you're pairing with a company that really is doing the right thing always, and for our environment, and making a better product for longer life expectancy of the products, because we know that we want to build, homes and, apartments and multifamily and, all types of structures to really last longer than we do, right? We want to have a legacy for maybe people in your office that after we're gone, they can say that was a project that you designed, 100 years ago, and that it's still, is performing as good as the day that you had it on your desk. So we're excited about that. So, we have everything from premium subfloor. Our Weather Logic is our WRB panel, and SmartSide is our engineered wood siding, which is the fastest growing siding in the US. So I hope you'll ask more questions at the end about our products, but I hope you enjoy the class today. So we will our class is actually the advantages of treated engineered wood siding, and our AIA portion of the class will start right now. So provided by Louisiana Pacific, and Acelab was a great partner of ours, allowing us to invite all of you to join us today. So you'll all get your credit. And so it will be submitted to the AIA CES, or you can request a certificate if you aren't an AIA member. So it's an introduction of engineered wood siding. And so the treated engineered wood siding. So a lot of times we'll reference actually TEWS in the presentation, and that stands for treated engineered wood siding. And really it's the use in residential, light commercial, multifamily, really, where the best focus is for that type of product to be used. It can't be used in all types of construction, but really there's a good bulk of projects where treated engineered wood siding really not just fits, but really excels as a cladding option for architects, and really for your customers to enjoy year after year. So feel free to drop any questions in the chat box, and we'll get to those at the end. But it also, we'll talk about the key benefits of the treated engineered wood siding, as well as the process of how that actually is manufactured, and how it can actually be used in fire rated assemblies. All right. Oh. My screen isn't working. I'm sorry. It's not advancing. Are you, sorry, folks.
No, you're good.
Is it advancing on your side?
It is not. We're stuck on the course description, but maybe you need to exit full screen and then come back in. Would that help?
Do I stop sharing? Sorry.
Sharing and then reshare. Okay. Are you able to see the correct page on your screen now?
Did it come up?
You might need to reshare.
Oh, there it goes. Can you see it again or no?
Click at the bottom and go to the green arrow and click share. Perfect. And then,
oh, it is doing. Okay.
Yep. And then hit the paper button right there. Yep. And do full screen.
All right. Cross our fingers.
Yep, we're all good.
Okay. Sorry about that, folks.
Perfect.
You think I'd be better at this by now, right? We'll talk about an overview of light residential, commercial, and multifamily, and where that treated engineered wood siding can be used best. In your types of construction. So type 5 combustible materials can be allowed on throughout the entire construction. An engineered wood or a combustible cladding option can be used. So really, so that is really the bread and butter for a treated engineered wood siding, and for even wood siding and vinyl siding. That's the high, the big portion of their business is being put on type 5 construction. Type 4 heavy timber. Traditionally, they're not using an engineered wood siding on heavy timber. They're going with a lot of glass, natural stones. They have very big budgets, right? And so sometimes engineered wood siding, even though it's a luxury and quality product, they're even using using the actual heavy timber as and really want the aging of that wood. And so but not that engineered wood can't play in a type 4 as long as it fits really under a type 5 type of construction there. If it's a type 4, but it's really going along type 3 guidelines, then it wouldn't work for that type of project. And then type 3 combustible materials, and we'll talk about that on walls only. And then type 1 and 2 non-combustible with FRT applications. And we'll talk about that as well in fire rating. And I hope you'll join us on classes on fire rating in the future. So type 1, fire restrictive. So all buildings are non-combustible, providing 3 or 4 hours of resistance in those wall cavities. Depending on the height of the project, there is a 40-foot height limitation on combustible sidings on type 1 fire rating. However, if you'll notice, there's really a lot of low-rise type 1 where it falls under that 40 feet, and engineered wood siding works perfectly on that. And if you'll notice in the picture that we're showing, that it actually shows a very dark colored siding. Many corporate brands that build type 1 construction, actually they specify engineered wood siding because it holds dark colors so well. They don't have that fading, and especially if their brand is tied to a dark or a bright or vivid color, the treated engineered wood siding really has its benefits that we'll talk about later in the presentation. So type 2, non-combustible, all building materials are non-combustible. This type of construction is in office buildings, medical buildings, some hotels. So really treated engineered wood siding really isn't the best bet. It's probably pretty hard to find a type 2 that's under that 40 feet nowadays, but it is possible. So if it is under 40-foot height from grade, that engineered wood siding can also be used. Type 3 also it has its height limitations on cladding. Those exterior walls are constructed of non-combustible FRT studs, steel studs, possibly a FRT sheathing of some sort. This is typically found in warehouses, multifamily, and years ago, calling on architects, you'd have architects that were doing, all type 3. Right now, we're seeing a lot of architects mixing more of type 3 and type 5 together because it's really fills out their project portfolio. And today's projects, this is frequently wood framing with that FRT stud with fire treated or FRT OSB or a magnesium oxide coated OSB type product to really give you that fire rating. And if it's under 40 feet, that cladding can go on a type 3 as well. So exterior walls, so heavy timber. So we're, in fact, if you ever, have seen woodwork presentations, they spend a lot of time promoting the heavy timber industry. And in fact, if you ever go on into some older historical towns like Chicago, if they pull back the walls, really they're heavy timber structures under all of that. They may even be covered with the terracotta blocking to give it even more fire protection, because of, after the Chicago fire, that was such a concern going forward, to build their structures more fire resistant. So but that interior is made of solid wood, and with and concealed spaces. This is commonly found in churches, commercial buildings, and warehouses, and corporate buildings. Universities are getting on the bandwagon with the heavy timber as well, for their forestry buildings, really taking advantage of the type 4, and really following the leads of many European architects as well. And then type 5, right? Wood framing buildings provide really little, or need little fire resistance, unless there's, zero lot line, or in the walkways, where you would need additional fire resistance. But engineered wood siding can actually play wonderfully into that. And we'll actually show even fire rated assemblies where you can incorporate an engineered wood siding. So this is typically found in residential, but also includes multifamily as well. And this is the fastest growing segment of the multifamily housing industry. And so it really takes advantage of the space and takes very little time to construct. So really attractive for building developers. So construction types by fire resistance. This is a good, just giving you the resistant hour resistance for fire rating, and what cladding is appropriate for those construction types. And this is a picture that, even when young people come on board at the company, this is something that I like to share, because this is really a good rule of thumb for even people starting out in the construction industry, to know if there is a fire rating component to the cladding itself. So combustible exterior walls covering construction types 1, 2, 3, and 4. Oh, sorry, 1, 2, 3, and 4, and then 5, of course, is wonderful for engineered wood, and many other types. So totally accepted by the building code. In fact, on the right is a 1-hour fire rated wall. There's also assemblies, if you are working in an area of the country where your energy ratings are more strict. This this assembly also comes with one where there's an additional layer of mineral wool to the exterior, so that you can even have a high performing wall, not just on the energy stance, not just on the fire portion of the assembly. So but that's the thing, if you're doing actually a 1-hour fire rated wall or less, you can actually do the calculative method. And so if you're doing the calculative method, if you're looking for siding, fiber cement will actually give you 5 minutes of calculated fire resistance or flame spread. Engineered wood will actually give you 5 minutes, and then vinyl will give you 0. So that's sort of, sometimes you're short on one of those 1-hour assemblies. You can't get anything from vinyl. So if you're ever working on that, that's always nice to know that you get both 5 minutes from both the types of siding. So cladding options for today's projects, and boy, have projects, come a long way, right? We work on, there's so many projects that, are built for, mass produced, right? We've got luxury builders, multifamily, and we're really, trying to make as many products that really reach and really suit the needs of our architect clients. So traditional wood cladding, right? Hands down, wood cladding is beautiful, but there's unfortunate the things that go along with wood siding, the maintenance issues, right? There is no hard, old growth wood available anymore. In fact, sometimes people are even getting cypress off the bottom of riverbanks trying to get old growth wood. But the fluctuating costs, there's a lot of time, especially for cedar. If you're in a cedar type market, cedar can be astronomically expensive different times in our construction cycles. And really, it's not an efficient use of our harvested trees, because if it does have knots or things like that, it's not really the best to use for siding. So if you're going to get a clear pine or a clear cedar, it's harder to source. And then a limited to warranty. Many times you'll get a 1-year warranty with a true wood siding. But things that people like about wood siding are those hard edges. So once you actually install it, you actually have that nice clean edge that you can't get with maybe a fiber cement or a vinyl product. You can, cut it in the field to do more intricate designs and corners and details. And those are some of the benefits of a natural wood product that some of the cladding options that came after wood siding really sort of fell short. So fiber cement, made of silica sand, Portland cement, and cellulose fibers. It's rot and decay resistance, right? If you look at their warranty, it'll give you a lifetime rot warranty, because there's really nothing to rot in many of because of what the substrate is manufactured out of. It does have fire resistant characteristics. So if you are participating, you're building in that type 1, 2, 3, and even 4, and it's over that 40-foot mark, many times fiber cement is an appropriate siding to choose for those particular projects. But the greater weight per square makes it brittle, actually, right? So it's a wet process, so it actually will continue to shrink after it's installed. And because it's so brittle, it really has some issues long term. So it also has a limited and regional based warranty. So if you're in a coastal area, you actually will have sometimes a lower warranty than if you're in, the Midwest, let's say. There's also issues with freeze thaw degradation. So the potentials of problems with fiber cement, in fact, the photo shows a stress crack, and I invite you to go out to a project that you completed 5 years ago with fiber cement and try to find that there isn't stress cracks, especially if any of the siding is cut smaller near windows and doors. If you've had to do a particular amount of site work where maybe you had to put in extra fill, you'll have some, or if you're near a body of water, you'll have extra settling. And so that will actually cause much more stress cracks in that project, right? We all know where there's stress cracks, water can get in and infiltrate your wall, right? And the last thing we want to do is really invite water management problems into our structures, right? So they're shrinking after installation. The picture in the middle on the right there actually shows what a fiber cement will look like after it's installed. So what they do is they butt the lap pieces together when they're installing it, very tight, hard as they can, right? And they install it. And then as it dries, it will actually shrink. And so then you will actually see those, lap joint. In fact, many places in the country, they're using H clips or lap trim so that it actually covers those, because it's really unavoidable with a fiber cement siding to not, and everybody knows that just caulk is only lasts so long. So H clip is really something that gives you a more long-term solution to water management problems and possible legal issues with that water infiltration. So it contains, and because it's brittle, there's a lot of job site waste. In fact, there's a lot of waste even at the middleman, at the distribution partners, because it cracks so much, even with them loading trucks. So that's waste, and really not great for our environment to have that much waste, right? All that product just going into landfills. So it contains approximately 45% Portland cement, 45% siloxane, and 10% wood fiber, but may be subject to OSHA Table 1 safety. So breathing apparatus, wet saws. So safety first. And so any product that has silica sand has to take those special, precautions. So anything that you're cutting on the job site. And so anytime that you can use a product that is maybe has the less chance of a silica dust, and having to deal with the OSHA standards, it's always better to choose those products. So brick and stone, the premium option, 50+ year warranty, durable, has fire resistant properties, lowest elastic mechanical properties, no need to paint, low maintenance. Really, it's really everything that you'd almost want on a building, right? If you can afford it and you have the time, because it's an expensive option due to labor. And depending on where your projects are, if you're up north, let's say, or if you're near where your labor may be more expensive, will take longer. If you're in the winter, it may take delays to actually install that as well. So longer installation time. Once again, that OSHA Table 1 compliance, because there is silica, it's a masonry product, but that warranty is wonderful, right? And if you're building that type 1, 2, 3, and 4, masonry is really a key, and sometimes a component of that fire rating on those projects. So vinyl siding is made out of 80% polyvinyl chloride. So it's often lower in cost. It's 12 foot in length. So vinyl comes in 12-foot lengths. Fiber cement typically comes in 12-foot lengths as well. So along with, especially if you're working on bigger projects, hotels, multifamily, schools where you have long walls with uninterrupted, openings where they're, big expanses of wall, those 12-foot lengths, really you'll see those, those gaps and lap joints, because there's 12-foot lengths. But it's got a shallow texture. So if you really want that wood texture, it's hard to find both a fiber cement and a vinyl siding. In fact, most architects, we talk about, wood graining on siding, and they don't like it because there's such a shallow texture out in the industry. And that's understandable, because let's face it, a lot of the original, asphalt siding, even the aluminum siding that maybe our parents and grandparents put on our house, they had that really shallow wood texture. They sort of gave us, the icks, right? So it's understandable that a siding with a wood grain, a shallow texture really sort of doesn't fit well with the architectural community. So, but it's less environmentally friendly, less rigid for more difficult siding installation, really hard to get those details looking accurate, usually not recyclable, not resilient to high temperatures or even freeze thaw. They can have problems with it becoming brittle over time, and limited color paint selections. So, and really, if you're going with a darker shade of a vinyl paint or vinyl siding, it can actually fade quite easily. And check on the delta ratings of the fade rates of your vinyl sidings, especially with those darker shades. And then, there's also products that are made that are a cellular PVC, that is much more expensive. It's going to have a lot of shrinkage issues. You won't have any rot issue or like a natural wood product, but the shrinkage problems will probably exceed even the shrinkage problems that you'd have with a fiber cement product. And then there's also a fly ash based siding. It's millable, it's strong, it's durable, it's paintable. You can even paint it dark shades, but very costly. So usually it's, that fly ash based siding is sometimes out of the budget of most clients. So they use it sparingly on projects. So we'll talk about engineered wood siding. So treated engineered wood siding, so TEWS, right? And we'll talk about why we call it treated, not just engineered wood siding, but a treated engineered wood siding. So there's structural and cladding properties all in that one product. It's actually engineered wood siding is rated by the APA, or the Plywood Association. And so that way it's actually got a structural rating. And in fact, some parts of the country use their engineered wood siding, not just for their cladding option, but for their structural options as well. They'll actually house wrap the studs and apply the siding directly over that house wrap stud. So really alleviating the need for an OSB or plywood sheathing on the exterior, and can save quite a bit of money when those OSB and plywood prices are expensive. So high elastic mechanical properties. So if you're in a area with a lot of shifting, or if you've done a lot of site work to prepare the site for building on it, you'll know you don't have to worry about cracking or settling problems long term. Resilient to different kinds of settling, whether there's a lot of movement. Assortment of products. For the companies that manufacture engineered wood siding, I would bet, there's not tons of manufacturers, but there are a few, and the ones that do make such a really beautiful selection of products that are durable. In fact, every one of the engineered wood manufacturers, or treated engineered wood siding manufacturers, actually have a 50-year warranty. So that actually says, quite a bit about the type of material overall. Most fiber cement siding only has a 30-year warranty on the actual lap, and a 15-year on their trim. So really, to know that the engineered wood siding industry as a whole feels confident enough that they'll give that 50-year warranty across the board, really sort of bring the light bulb goes off. So it's got that realistic deep graining pattern. And you'll see in the video on how an engineered wood siding is manufactured, whether it's a wet process or a dry process, how they can get that really dark graining. In fact, I have a picture. Here's an actual sample, and you'll see that there's actually some dark graining pattern that actually looks like a true cedar product versus a fake embossed type product. And then a smaller carbon footprint, and it's a renewable resource. So we'll talk about why, environmentally speaking, engineered wood siding is great for environmental choices. So the history. So it started out in the 60s, between 65 and 95. And typically, if you were making plywood or OSB, you probably had a engineered wood siding company back in the day. And so, they would take it, they would clear cut a forest. It didn't much matter if it was hardwood or, a mix of hardwood and pine. Didn't matter if it was a wet, rainy season or dry season. They made almost like a cookie dough out of it and would bake it. And so the problem was that there wasn't quite a lot of science behind the process. And so you might have a batch that, is, still on homes today that are from 1965 or in the 70s, and it still looks, pretty darn good. But then there were some, times when you had maybe a rainy season and it was all pine, and maybe it wouldn't last too long. So a lot of those companies really got out of the industry, right? They were like, there's no way we can do this. It's too much trouble. And that's when in the 90s, they actually came around with a dry process and really adding the better resins. You'll see that in the manufacturing process, how the resins changed, right? It's not a phenolic-based resin. Phenolic-based resins, and you can talk to anybody in the engineered wood industry, is a water-based, more inexpensive, less dependable aspect of resins, right? And the MDI resin, we'll talk about what MDI resin is really allows for that product to shine and to do so well, and to really, make any engineered wood product better. So that process was in 1997, that dry process with wood strands, non-phenolic resins, and those binders. And it evaluated by the APA, that strength and stiffness allows for 16-foot length. So that's across the board, no matter what the manufacturer is. So less seams makes a more beautiful project, less chance for water infiltration and less breakage, so reducing that job site waste. So the benefits of strand treated engineered wood versus that fiber that all those companies started out with back in the 60s, superior impact and wind resistance. So because of those those fibers, those strands that are interlocking and going in different directions, it gives you that strength that you can use for structural, but it also will keep that siding from cracking and and taking any dents on, even from hail or a kid hitting it with a baseball or rocks flying up from the lawnmower. So the resins, in the resin, they actually put zinc borate. This will actually keep fungal decay and termites from finding engineered wood siding as a food source. So that's the thing. So back in the day, back in the 60s, those were not added to the old engineered wood siding. So night and day, right? It's the difference between how did you watch your movies in the 80s, maybe on a Betamax, and now it's all digital. That's the difference. That's how different engineered wood siding is today. So or engineered treated wood siding. So designed for freeze thaw tolerance. So if you've ever seen, especially if you're north of the Mason-Dixon line, that can be a real issue with some siding brands. Engineered wood siding, you will not have that type of product and those 50-year warranties. So here's a typical fence for testing. They test structural performance, moisture resistance, chemicals. Doesn't matter what kind of chemical, lawn chemicals, cleaning chemicals, they test everything, the weatherability, the durability, and really even tension strength put on that to even mimic settling. Salt spray, sand blowing, you name it. So it's also tested by third-party research companies, research colleges, industry associations, you name it, and different manufacturers, all doing these different test walls and tests, so to really put it through its paces. So the composition of that treated engineered wood siding is we'll talk about the conversion of logs, the efficient use of that raw material, how the wax binders and overlay are added. And you'll want to pay attention to the video where that overlay, it almost looks like paper, but it's not. It's actually a hard primer layer that actually protects the substrate. We'll talk about why that's so key in the process and what benefits you actually get out of it. And then that zinc borate to repel insects and any mold from growing, right? Mold can grow anywhere, right? As long as the spores are everywhere in our environment and damp. And so zinc borate really helps with that. So MDI resin, and this is why everybody calls it MDI instead of, so it's methylene diphenol dicyanate. And the more MDI resin that's in an engineered wood, it's closely related to the resin actually in Gorilla Glue. And so we all know it's not a new resin, right? But we know how fantastic it is. And more companies are actually using MDI resin to really help the product last. And what it actually does is it absorbs into the strands and keeps the wood strands from taking on any water or moisture. So it really keeps it as, really almost any problems that could possibly come from a natural wood product is really undone by the addition of between the MDI resin and the zinc borate. So pretty special. So logs are debarked, cut into strands, dried, screened, and we'll see this all in the next video.
When you're choosing new siding, you want to make sure it'll last, standing up to weather and time. Your new siding has to be beautiful and durable. LP Smart Side Trim and Siding isn't traditional wood, and it's not typical OSB. It's engineered wood, designed with intention to its core, backed by robust technology, and built with the care and detail you expect. It delivers advanced durability for longer-lasting beauty. But you've probably heard that before. So let's go back to the beginning. LP Smart Side Trim and Siding may not be traditional wood, but it does start there, with aspen logs, conditioned and softened so they're ready to work with. Aspen trees can regenerate from their own roots, helping LP to make sure the resources they use are fully renewable. And when bark is removed, it's used to fuel the plant. So 99% of each log is used during the process. From there, logs are shaved down into strands about the thickness of a business card and dried out. The strands are tested often along the way to ensure each piece of siding leaves the plant exactly as it's intended. Next, in a drum that acts much like a huge tumble dryer, each strand gets covered with a mix of advanced binders, waxes, and zinc borate. These work together in order to help provide multi-layered protection against moisture, fungal decay, and termites. This is what LP calls the Smart Guard process. LP Smart Side trim and siding isn't just protected from the outside, it's durable down to each strand. It's also backed by an industry-leading 50-year limited warranty, based on scientific data that comes from testing in a wide variety of climates and conditions. Once the strands are treated, they're arranged into layers. Even this part of the process is engineered for long-lasting siding. LP Smart Side trim and siding's layers are purposefully oriented in different directions. This intentional design guarantees strength where it's needed most. Next, the moisture-resistant overlay is added as a final safeguard against moisture. It is firmly adhered in the next part of the process, the press. At this point, LP Smart Side trim and siding is much thicker than when it's used. But pressure and heat change that. Each sheet is compressed to ensure the resins are fully cured and the texture is firmly embossed. To finish, the edges of each sheet are trimmed, cut to size, and primed. They're ready to be packaged, shipped, and installed. LP Smart Side trim and siding is wood that has been engineered for durability and beauty. And it's engineered wood you can trust, combining technology and style to offer you advanced durability for longer lasting beauty. LP Smart Side trim and siding is a product you can rely on. Learn more about LP Smart Side trim and siding at LP.
All right. So that process in that video is very, that's you'll actually if it's a manufacturer doing a dry process, they will have very similar a process. And if it's wet, they would actually, the first portion, they would probably use most of those companies are based up north, some in the south, but in pine type areas. And they'll actually do the wood flour, but they are adding MDI resin and to counteract, any issue you would have with a natural wood type product. But this is a neat slide that actually shows the impact resistance. And so different sizes, everything from golf ball, but engineered wood siding actually has a projectile warranty that you don't get with other types of siding. So really highlighting the durability, whether you're working on a multifamily project where that multifamily developer is going to hold on to it long term, or if you're doing a luxury home and this is their last home, they don't want to have to worry about their, even if they're in a hurricane prone area and something flew against the siding, that they're going to have problems. So oh, give me 1 minute. I'm going to stop sharing again. So
Let me know if you need any help.
okay. Oh. Or
I see the same screen as before.
how's it now?
Good. I see the durability page.
Okay, good, perfect. Okay. Oh, so good. Hold on. Can you advance my screen? And I don't know if you can.
Not. Can you exit full screen mode and maybe we just see it not full screen?
Oh. What do I hit? I'm sorry. Oh, there.
Right there. And then if you, perfect. I see TEWS installation.
Oh, perfect. Okay, perfect. Okay, it cuts with standard tools. It's lightweight. You actually use regular wood saw blades. So no wet saws, no special breathing apparatus because you're not concerned about that silica sand. So a regular dust mask that they would cut their 2x4s with comes in 16-foot lengths, faster installation than fiber cement, better paint adhesion due to the overlay process. So versus painting over a porous surface. So that overlay, right? It also will retain those darker shades that you remember seeing in that, video or that one type 1. So many brands that identify with a darker shade exterior are now starting to add treated engineered wood siding to their specifications because they know that it's going to retain. They're not going to have those problems with efflorescence, which is the calcium leaching out, and really the durability. Oh. Did you know what? I think can you?
What'd you say? Sorry.
I'm chairing, Sharon.
Oh, fantastic. Okay.
Perfect. Feel free to let Rodrigo know when you want to switch.
Yeah, go right. Yeah, you go right ahead. Oh, a general installation. So, just like every other siding, there is a minimum 6 inches above grade. But what's nice about engineered wood siding is that all the companies that manufacture it have each individual piece has a individual piece warranty, where many fiber cement companies will actually, if it ends up being where you draw it perfectly 6 inches above grade, but it ends up they do the landscaping, it's 2 inches above grade. Well, with fiber cement, that can actually make the project suspect in the eyes of the warranty. And so with engineered wood siding, treated engineered wood siding, that does not occur because every piece has its own warranty. That's pretty special. So but yeah, that six inches is across the board in the science in the industry for science for siding clearance. Go ahead, Frederick. Perfect. So beauty and aesthetics, classic appeal of wood, right? What's nice about engineered wood siding is it has those true hard edges. And so here's a piece of trim, and you'll actually see how nice and crisp that is. And so whether you're working on a historical, project or an addition to a historical project, or, a luxury project, multifamily, that gives you that beautiful sight line and hard edge that really gives you the beauty of a traditional wood without any of the worries that you would have. So, but you get that cedar texture that you actually see there, a smooth or brushed smooth texture. It actually has fine, a hand brush finish, really many design options, everything from a stucco panel, nickel gap siding. Because of how it's manufactured, you can actually make it'll have different curves within it so that it actually works better. It naturally benefits the design of many different kind of siding, and that distinctive appeal and bigger shadow line. Go ahead. So architectural elements, just different ones. That there's that dark siding that really loves a darker shade. And so you can do everything from board and batten, panel. In fact, it works wonderfully in a kerf system. So if you're doing an aluminum kerf or a cellular PVC kerf, it actually works with the kerf system. So engineered wood siding, treated engineered wood siding will typically, because of that dry process, you saw that it was actually, those strands were dried before it was actually, before the layering process. Well, those are about 5 to 6% moisture. And so even with all the resin that soaks into it, it's still dry. And so when it gets shipped out, it actually acclimates and will expand just slightly. It'll actually expand better into the kerf system, where I've seen many times on fiber cement projects where it actually shrinks part of the beast, right, is that it'll shrink outside of the curve system, and you'll need a secondary fastening system to hold that siding into place. So another benefit of the process of treated engineered wood siding. Go ahead, Rod. So sustainability factors of treated engineered wood. We'll discuss that really quick. So made with responsibly sourced wood fiber. In fact, if you talk to anybody in the wood industry, it would be almost harder and harder to find, wood that's not sustainably harvested. It makes more money for the tree farmers out in the United States and Canada, where these types of companies are producing the treated engineered wood siding, and so it really works well. It works well for good manufacturers to be buying that type of product, and it's good for our environment. The strand process uses aspen, which actually regrows from its own roots, and the life cycle on it is much quicker, about 50 years for the harvesting period. So that really we're on the second, if you're in 1997 or in the 60s, really, when they started making, they're on the second harvest in some of those areas for that siding. So SFI is recognized by LEED, and that land is reforested. So they, because they really take care of the forest land, they work with those communities. Many Indian nations also harvest the land, and environment, the environment is key to the First Nations. And the fast growing trees really make it an optimal product for sustainability and for our environment. Go ahead. So those renewable materials, those aspen trees, and the thing is, though, aspen, if you don't harvest it, about the max time that an aspen tree maturity is about 50 years. 100 years is actually when it starts to die and it falls over. So if you don't harvest it, it actually will fall over. It litters the forest floor and then can actually give fuel to forest fires. So by harvesting it to make siding actually is even better for forest management. So efficient utilization, they actually harvest in special areas so that you have large growth trees mingling with small growth trees. It sets up a whole biosystem for the animals that live in those areas, especially moose. They like to eat the young aspen trees, but they like to bed down in the larger aspen trees. So all of this is taken into account when those harvesting methods are put into place. So 99% of that log is used, the bark is used for biofuel. There's really an intentional manufacturing that makes it really naturally carbon negative, and those low emitting binding agents like MDI resin and zinc borate, water inhibitors, really plays into part with the really environmental friendliness of treated engineered wood siding. And because it's a lighter product, about a third the weight of fiber cement, it's less energy to transport, but it's also less energy to produce. Go ahead, Rob. So carbon neutral is when the amount of CO2 emitted during the product's production is equal to the amount of CO2 of the product removes from the atmosphere, and carbon negative is when the amount of CO2 emitted during the product's production is less than the amount of CO2 the product removes from the atmosphere over its lifetime. And so nowadays we're getting so many people saying, oh, but if you say you're a carbon negative company or a carbon negative product, people are always asking, well, do you buy carbon credits? That is a valid point, right? No, right? You want to find companies that actually truly manufacture carbon negative products and really walk the walk, right? Because it's too easy just to buy carbon credits in this day and age. So I think that carbon negative sometimes gets watered down when we realize that it can be offset so easily nowadays. So go ahead, Rod. So why is strand TEWS carbon negative? Those renewable resources, right? Those that aspen that naturally regenerate. In fact, there's a documentary. I believe the forest is out west. Idaho or something. I was just told last week about it. It's about this root system of the aspen trees out in that area. So the aspen trees typically grow north of the Mason-Dixon line, but there's that intentional manufacturing, really using as much of the wood and trying to harvest as close to the factories as possible, efficient utilization of our resources that are so precious to us all, right? So we want to make sure that we're using it as best as possible. Go ahead. So building better with carbon negative siding. So 54% less greenhouse emissions from treated engineered wood siding strand products than fiber cement, based on product and science and data sheets from different manufacturers that have been studied. 10 times more carbon stored in the treated engineered wood than the fiber cement products on the market. Go ahead. So summary, treated engineered wood siding is an option for types 1, 2, 3, 4, and 5. You will have those height restrictions up to 40 feet, but really many projects, whether that be commercial, multifamily, more residential in nature, engineered wood siding, not only because it outlasts the competition, whether it be vinyl or fiber cement, it holds up better. It actually the maintenance is less because you're not going to have those stress cracks, that impact, because it holds up to 180-mile-per-hour winds, 200-mile-per-hour gusts. I live in the Carolinas. When a hurricane hits the Outer Banks, you'll see them just tearing off old vinyl, old fiber cement, and filling up dumpsters and dumpsters. And engineered wood siding actually takes those storms and holds it, so they don't have to throw that siding away. So pretty great for the environment and great for the clients that had architects that were so thoughtful in their choosing of the product. So treated engineered wood siding is tested for moisture, hail, and termite resistance. Because of that zinc borate and MDI resin, they don't see it as a food source. And it provides an alternative to other types of siding, while really being friendly to our environment, and knowing that we're specifying products that are really longer lasting and great for our clients' projects. Next. Thank you for coming. This concludes the AIA portion of the class, and we'll take questions. If you'd like to read out the ones that are already in the system, myself and Rodrigo Cadillo is also the manager of our architectural team.
Perfect.
Valerie Cowell is actually our multifamily head of our division. So she's joining us today as well. She's our director.
We have just a few minutes, so I'll go in order of when the questions were asked, and any that we don't have time to get to today, they will have your contact information to follow up with you directly after this presentation. This first question, it's a little bit lengthy, so I'm going to read it and let me know if you need me to re-explain. How does the thermal performance of LP TEWS, TEWS, compared to sawn lumber wood siding boards? I ask because my state's energy code has accepted values for overall wall performance and wood siding boards, and T111 are noted there with U values that can just meet current standards. For reference, fiber cement and vinyl aren't mentioned as siding materials in those assemblies, but it would seem that they would have lesser performance.
Correct. So in fact, we actually have the data from the APA as well for their R values. So I'll get, if you can save that person's name, or if you'd like to email us, that would be great. We'll be sending out an email with our contact information. Thank you for attending. But we can send you those R values as well. That really is done by the APA and online as well. But
Perfect.
yes, it does help in energy rating, and because it's so resilient and not as brittle as well, right? We actually have been doing more sound transmission testing as well, because we expect the sound transmission ratings to be improved over vinyl and fiber cement. Sorry, go ahead. That was sort of what I just threw in.
Definitely. If you allow me to add something
Oh yeah,
to this
right.
question. So let's remember that our values depend on the mass, the thickness of the material. So we do offer different thicknesses when it comes to the lap siding. Anything from 3/8 thick to 19/32 thick as well. So depending on that thickness, you're gonna have better performance for that energy code compliance. But yeah, we can follow up with that information.
Great. Okay. The next one down is, what is the importance of wood siding and what impact does it have in our environment?
Well, because it's made from a renewable resource, right? Aspen is the fastest growing tree that you could, if you're doing a strand process, right, over a wet process where probably pine is being used. Both are, very good types of siding, but the strand really will give you a much better, longer lifespan for the product as well, right? And it's not as susceptible to poor installation. So fiber types of siding will actually, you could have problems with the installation long term, and that will also be better for the environment. So if somebody, maybe the siding wasn't installed quite right, if it's a strand, it's much more durable to even a iffy installation that you wouldn't have to then end up in a landfill long term, right? There's really long-term benefits to the engineered wood siding and the strand process itself.
Perfect. And just to respect everyone's time, the rest of the questions you guys will get in the webinar poll, and either Mallory, Sharon, or Rodrigo will be following up with you after this presentation. Thank you so much. And does anyone have any final thoughts before we end this webinar?
No, Lisa, I'll just say, again, Sharon, thank you for walking us through the content. We are so excited to be here, and we really value our partnership with Acelab. So looking forward to hearing some follow-up questions, and please reach out. Thank you for the time.
Bye, everyone. Thank you so much, Sharon and Mallory and Rodrigo. Bye.